my research is about hydrogeological conceptual model in the middle of Pandu Blatung groundwater basin. Before that, I would like to introduce my team first. The first one is me, Biosari Chaningsi. The second one is Mr. Kurnianto Yustiawan. And the third is Mr. Doni Prakasa Eka Putra. And the last one is Mr. Salahuddin. We come from Department of Geology and Engineering, Gajah Mada University. So this is my outline, introduction, methodology, result, and conclusion. Introduction. Pandu Blatung groundwater basin is one of the groundwater basin with massive groundwater pumping that located in Java Island. Groundwater use is increasing rapidly, especially in the middle of area Pandu Blatung, Kedung Tuban, and Kaduna. Sorry. Due to the high produce of agricultural commodity in the Goa region, so that these three areas have become the research area. For the last ±20 years, Pandu Blatung groundwater basin indicated decreasing groundwater level from the borehology. Groundwater modeling can describe complex hydrogeological subsurface conditions, and the basis of groundwater flow modeling is a conceptual model. So the purpose of this research is the first one is groundwater flow direction, and the second one is hydrostratigraphy of the research area. So this is my research area in Java Island, in the Goa Regency, and the middle of Pandu Blatung groundwater basin. Methodology, the first one literature itu collecting data, analyzing data, and conclusion. So this is the first one about the regional geology. From the research area composed of alluvial deposits consists of sand, gravel, clay, silt, sandstone, limestone, sandstone, and sandy clay. This is from Pandu Blatung geological map from Peta Geologi Lembar Ngawi and Peta Geologi Lembar Bojonegoro, Jawa Timur. The second one is regional hydrogeology from hydrogeological map of research area. There is sources Peta Hidrogeologi Indonesia Lembar 7 Semarang. I'm sorry. In the research area consists of extensive productive aquifer, moderate productive aquifer, and locally productive aquifer. The aquifer layer consists of silty sand, fine sand, and coarse sand. Groundwater level observation and borehology. The blue one is borehole point, and the pink one is well point. A total of 74 groundwater level from well and 91 borehole are collected, so in the PG design. The well evaluation is to understand the natural groundwater system. Meanwhile, the borehole analysis is to determine lithology subsurface in the model area. Observation well and flow net, this is the result. Total of 74 points are collected from the observation well. The water level varies between 21 MISL to 123.6 MISL. The lowest water level MISL is located near the Bengawan Solo River in this area, and the highest water level MISL is located southwest in Kendeng Hill in this area, and the second highest in Rembang Hill. The pattern and the direction of groundwater flow from the hill to the Bengawan Solo River and the north as the river flows. The boundary, the first one use a constant head boundary in Rembang Hill, and the second one I use a river boundary. The first river boundary is Grogol River, the second river boundary is Pado River, and the third river boundary is the Bengawan Solo River. This is the result of borehology, but I just pick some of the samples from the secondary data. From all of the borehology, we can compute the lithology subsurface condition from borehology consists of this layer. The first one is topsoil, gravel, sandy gravel, sand, sandy clay, sandy limestone, silt, clay sand, clay, and silt. The last one is the results of the borehology cross section. I cross 5 cross section. The first one is cross section A to A. The second is cross section B to B, and then C to C, and then 1 to 1, and then 2 to 2. The conclusion is there are one unconfined aquifer in the top, and 3 layers of confined aquifer, and 3 layers of aquifer. The unconfined aquifer in the subsurface area, the thickness varies from 5 to 20, and the layer of confined aquifer with depth from 10 to 75 meters from the ground, with thickness varies from 8 to 60. Sorry. And then the 3-layer of aqueous with depth from 5 to 100 meters from the ground, with thickness varies from 5 to 65 meters. And the conclusion, the first one is background water on the groundwater basin flow from the hill Rembang and Kendang to the Bengawan Solo River and the north as the Flow River. The hydrostratigraphy in the research area consists of an unconfined aquifer with a maximum thickness of 20, 3-layer of confined aquifer with thickness varies between 8 to 60, and 3-layer of aquifer with thickness varies between 5 to 65. The lithology comprised the hydrostratigraphy from topsoil, gravel, sandy gravel, sand, sandy clay, clay sand, clay, silt, sandy, limestone, and silt. The hydrogeological conceptual model provide essential information for groundwater model in the middle of the Randu Batung groundwater basin. And that's all for me. Thank you for your attention. I'm sorry for the mistake. Good afternoon. And this is my references.
Okay, thank you, Miss Dwi Lestari. Maybe this session have a question for Miss Dwi from Miss Esther.
Excuse me. May I give a question?
Oh, okay.
Miss Dwi, I just want to know what is the constraints that the method you use in your research or your study. Thank you.
Okay, thank you for the question. The first one is description and about the observation. The first one I used from the well. I know the water table from the well is about 74 well in the research area. I measured the water table from each well and to know about the groundwater flow direction. And the secondary data that I use is morphology. So I know the lithology subsurface in the area. The morphology is from secondary data from the BBS Pengamajuan. So the morphology I analyze the subsurface lithology subsurface. Okay, that's all for me.
Mr. Robi?
Yes, I'm sorry. I can catch the answer. I mean, what is the constraints or the weakness of the method that you use in your research?
I'm sorry, I don't understand
what is the constraints or the weakness of the method that you use or your in your research? The method or the model, yeah.
This is about just the conceptual model. I mean, your question is about the flow model. This is the next step from my research area. This is just the conceptual model. It's just the lithology subsurface. So from this model can be developed into the groundwater model.
So there is no constraints of the conceptual model. Okay.
Just I think because of the data, the standard data just use apa was this morphology.
Okay.
So maybe you can compare with the PAS or geoelectrical investigation, so you know what the lithology subsurface in 2 different methods.
Okay, thank you, Ms. Dwi.
Thank you.
Thank you, Ms. Dwi, and thank you, Mr. Robi Hambali. Maybe the question number 2 from Esther. Ms. Dwi, the question was from Esther is, can you categorize the result of lithology subsurface from your research for each aquifer and aquiclude? Maybe Miss Esther, you can speak with Miss Dwi.
Okay.
Yeah,
Maybe.
thank you.
Yeah.
Okay, I think the question is mentioned with the moderator.
Okay. Thank you. Maybe the question you see about my lithology subsurface in my presentation. Okay. There's I got two layers. The first one in aquiclude and the second one is aquifer. So from my lithology subsurface, I can conclude the aquifer my aquifer layers consist of gravel, sandy, sand, and sandy clay like this. And the second one about the aquiclude is consists of clay, silty, clay sand, shell, and that's all from me, Mr. Esther. Miss Esther, I'm sorry.
Okay, thank you, Miss Dwi, for the answer.
Okay, is it clear? Okay, thank you. Maybe we would like to, we come up to the next session. I would like to invite, sorry, Mr. Esther Estefan or Miss?
Oh, Miss, I'm sorry, yes.
Oh, okay, sorry. Miss Esther Estefan Tantama to prepare and present the slide with the title Nitrat Contamination Level in Groundwater of the Randu Blatung Basin and its surroundings. Please, Miss Esther, the screen is yours.
Yeah, thank you for the time, Miss Moderator. Is my screen is good?
Can you slideshow the screen?
Okay,
Your PowerPoint.
yeah. Thank you for the time. Today I would like to present our study with the title of Nitrate Contamination Level in Groundwater of the Randu Blatung Basin and its surroundings. But first, let me introduce our team. The first one is me, Esther Esteban Tantama, and then Mr. Manggala Aji Kumara, and Mr. Doni Prakasa Eka Putra, and the last one is Mrs. Gayatri Indah Marliani. We are from Department of Geological Engineering, Gadjah Mada University, and Ministry of Public Works and Housing Indonesia. So this is the contents of our presentation. The first one is introduction, and then material methods, and results and discussion, and the last one is conclusion. We start with the introduction. The groundwater is a water resource to fulfill the daily needs and agriculture and farming. So the people in Randu Blatung Basin and its surroundings are also using the groundwater for the mentioned need. And the groundwater itself is in the Grobogan, Blora, and Bojonegoro Regency. And these three regency have positive rates of population growth. We can see here that there's a population growth every year in these three regency and have a big agriculture area. And the livestock is also so many, hundreds and thousands of livestock there. So the activity also produce the contaminants here. We know that there's a nitrate and chloride in the fertilizer and the chloride and nitrate in the waste of the livestock and domestic waste. So the contaminants will enter the soil and mix with the groundwater. And if we consume more than 50 milligrams per liter of nitrate, it can cause blue baby syndrome in infants and gastrointestinal cancer in adults. So this is very crucial to know the nitrate and chloride content in the groundwater of Randu Blatung Basin and its surroundings, so that later step can be taken to prevent the groundwater contamination from getting worse. So this is the study area of this research. We can see here that the Randu Blatung Basin is surrounded by two hills, the Rembang Hills on the north side and the Kendeng Hills on the south side. And so based on the topographic condition, the elevation on the north and south side is higher than the basin itself. And we can see here the sampling points of this research. The circle one is from the duck well samples, and the diamond is from the palm well samples. So this is the methods of our research. We use 35 samples of groundwater. The 15 is from palm wells and 20 samples is from duck wells. The samples kept in the HDPE bottle and in cooling box to prevent the microbial activity and carbonate deposition in the samples. Then we filter the samples with 0.2 micrometer of filter and then analyze the anions using ion chromatography from meterohm. And then we compare the nitrate and chloride content in the groundwater using the comparison diagram to analyze the nitrate resource. So this is the results of nitrate and chloride content in the groundwater of Randu Belatung Basin. We can see here that the nitrate content in the duck wells is between 0.3 to 52 milligrams per liter, and in the palm well is between 0 to 29.7 milligrams per liter. And the chloride content in the duck wells is between 2 until 117 milligram per liter, and in the palm well is between 4 to 271 milligrams per liter. The permissible limit of nitrate content in the drinking water based on the WHO and Ministry of Health Indonesia is 50 milligrams, while the chloride content that allowed is 250 milligrams per liter in the drinking water. So we can see here that there's a sample that exceed the limit of the permissible limit, and also here is the location of the sample that exceed the limit. So the first one is SGL3. The nitrate content in SGL3 is exceed the permitted value from WHO and Ministry of Health Indonesia. It can be caused by the high activity of agriculture in Kedung Deman district, because 10% of the agriculture area in